Hey my dear warriors, welcome. This is your Captain Shreyas here. Hello Shreya, hello Abhirami, Riddhi. Good morning my dear warriors. Yes, the live has started and today's session is your 11th syllabus JEE 2023 and JEE 2024 crash course exclusively for you. I hope you guys are doing fabulous. You guys are all excited to start this session on simple harmonic motion, or you can say oscillations, and your waves on a string and sound waves. In general, the waves portion of your 11th standard. So let's begin the class and make sure you smash the like button, also hit the subscribe button, and also do not forget guys, down here there is a crash course as well as there is a feedback form for all of you to fill. Okay, it's a very simple form where you have to mention which grade you are in, what board you are studying, and what is your preferred language of study, and that's it. Okay, it's a very small form. It is going to take you less than half a minute to fill, so make sure you fill that form. Nice to see all of you. Hello Sakshi, hello MD Farooq. Guys, welcome aboard to the 11th standard syllabus JEE crash course of SHM and Waves with me Shreyas, your physics master teacher, teaching kids, producing results, not just any results, awesome results, sending kids to IITs, top-notch institutes over a decade. And today's session flow is going to be short notes already shared on the Telegram. You need to check that out. Then brief revision. After that, problem solving and tips and tricks will be given. You're going to solve the previous year questions. Then you're going to get the session PDF, and you are also going to get the DPP for your home practice towards the end of the session in the form of PDF in the Telegram channel again. So let's begin the class. Thank you for liking, thank you for subscribing. So let's begin. Good morning Winter. Will I also teach in the crash course? No, I will not be teaching the crash course, but teachers exactly like me will be teaching. Hello Thanga, hello Blessy, nice to see you. I read all your comments guys in yesterday's video. Thank you so much for putting up such lovely and heartfelt, I would say, comments. So it means a lot when you write something about the channel, about me, about whatever you are doing in life. It need not be about me. It could be just about you. Sir, I'm doing this, I'm doing that. I feel really happy. I might not reply to everything, but it feels really nice to know what you guys are doing. Thank you so much guys for staying in touch. Shreya, you can get more than 600. It is definitely possible. And I'll tell you how to do that. Maybe you can leave a comment or you can contact me on Instagram. If possible, I'll try to reply, but I cannot guarantee. At least on comments, I'll try to reply. Now, see guys, in simple harmonic motion, first thing is basically the equations of SHM. Equations of simple harmonic motion. Now, what is simple harmonic motion? You should also remember one more thing. That see, there are few kinds of motion which are basically periodic in nature. They are periodic in nature. There are some kinds of motion which are oscillating in nature. They are two different things. There are things which could be periodic but not oscillating. There could be things which are oscillating but not periodic. Example of periodic but it is not oscillating is a revolution of moon around the earth. Moon revolves at regular intervals, 28 days around the earth. But it is not oscillating. It does not go here and then go here. It's not oscillating. Things could be oscillating, like I am going here, I am coming here. I am going here, I am coming here. It's oscillating. But it may not be periodic. Sometimes I move aram se, then suddenly I come here, then suddenly I go here, then I just do time pass and then I go here. It's not repeating at regular time intervals, fixed time intervals, but it is oscillating. But those things which are periodic and oscillating, that is what we study as oscillation or periodic oscillations, you can say. So this is exactly what you generally study. So these motions, example, simple pendulum, it is oscillating and it is periodic, fixed time interval. Or a spring mass system goes back and forth. Or any force which is restoring in nature will cause oscillating and periodic motion. A special case of that is basically your simple harmonic motion. It's a special, very unique case, simple harmonic motion, where The motion is a sine function or a cosine function of time. It's a pure sine or pure cosine function. Nothing else is there. There is no impurity in that mathematical equation. That is basically called as simple harmonic motion. Prem, I'm much better. Haris. Thank you so much, guys, for asking. So there are some important things about simple harmonic motion which you should know. So when a particle goes back and forth, back and forth, back and forth like this along this line, okay, it's going back and forth along this line, then this point where it turns around, that is called as the extreme point. This is called also as the extreme point. The midpoint is called as the mean position. Mean position, extreme position, right? And then other things like this to this is basically called as your amplitude. This is your amplitude of oscillation. At this particular point, your speed is maximum. Speed is basically maximum. At extreme position, the velocity or the speed is basically 0, right? That's how it works. And the exact opposite is true for acceleration. At this point, the acceleration is 0. At this point, the acceleration is basically maximum. Same thing over here. Acceleration is basically maximum. So it's exactly opposite of speed. Speed will be maximum speed. It will go towards the mean position with maximum speed and slowly decelerate. Stops, turns back, maximum speed, stops, turns back, maximum speed. That's how it goes. I hope you remember all these things, right? You also have few more terms like the time period, frequency and all of that. So frequency of oscillation, how many times it goes back and forth in 1 second is 1 by the time period. Also remember, omega is nothing but 2 pi f, or you can just call it as 2 pi by time period, which is the angular frequency. This is nothing but angular frequency. It's not the speed, it's the angular frequency. This is very, very important equation. Yep. Okay, I hope all these points are clear. I hope all these things are refreshing the memories back of simple harmonic motion. Guys, let me tell you, if you want detailed study, some of you will be like, sir, I have not studied SHM at all. My free playlist is available on the channel. It's called as a Nurture series. All beautiful playlists are maintained. Watch that. Okay, detailed classes are there. But this is more of like revision. At least I expect you to have, certain knowledge of SHM. Great, Jishnu. Very good, Arindam. Yes, it is a projection of circular motion. Hello, Kalpana ji. Okay. Now, what are the different equations? Equations as in, you tell me the time, I'll tell you where it is. You tell me where it is, I'll tell you what is the speed. You tell me where it is, I'll tell you what is the acceleration. You tell me what is the acceleration, I'll tell you at what time is that acceleration. So all these are going to give you enough information about the motion of that oscillation. So the first equation being of position. Position is generally A. You can use cosine also. There is no harm in that. Omega, the same omega, t plus phi. And then you also have velocity, which is A omega cos omega t plus phi. You also have acceleration as minus A omega square sine omega t plus phi. If you are wondering what this phi is, it is called as the phase constant. It is called as the phase constant, or just the initial phase, In fact, this entire thing, which is omega t plus phi, is called as the phase of SHM, the phase of the SHM, the total angle inside, omega t plus phi. If you put time as 0, this term will vanish. What you get is only phi. That is why it is called as the initial phase. This whole thing is the phase. This is called as the initial phase. Phase is basically just like what it means. What you have heard of phase before this in geography, right? Phases of moon, the different phases of life, right? From birth till the time you die, or the phases of moon, new moon to no moon, right? So same way, phase of SHM tells you the situation of the SHM, as in where it is. The angle decides where is the SHM starting its journey from. Is it starting from here? Is it starting from here while going this side? Or is it going there when you start the timer at 0? That's what it is. I hope this is clear. Balaji, I won't be doing thermo bacha. I will be sharing the PDF. I have already shared it already. So you can watch my earlier thermo classes. The solution to all the problems in life is search for Shreyas sir topic name. Shreyas sir this strategy. Shreyas sir that exam details. So that is the solution. Okay. So these are the main things. Apart from that, more equations like this one. Velocity is nothing but omega root of a square minus x square is also important equation, and acceleration is minus omega square x is also an important equation. In this particular equations, also keep this in mind, my dear students, that this a omega is basically your max speed. This is your max speed. A omega square is your max acceleration, because this term or this term's maximum value is 1. So 1 into any number is that number. So maximum speed is this value, maximum acceleration is this value, because this maximum is only 1. Is that okay, everyone? I hope you have recollected most of the things. Similarly, we can also talk about kinetic energy and the potential energy. Kinetic energy is just half mv square, and you can put the value of v from here, or you can put the value of v from here. Similarly, the potential energy is half k x square. Either x is given, or you can just put x from here also. It's up to you. The total energy, which is kinetic energy plus potential energy, is always a constant. It is half the spring constant times the amplitude square. This is constant because of conservation of energy. The total energy is half k amplitude times square. I hope this is very, very clear and you remember this formula. The sum of kinetic and potential energy is the mechanical energy, which is constant or conserved in an oscillating spring mass system. You might have seen the graphs as well before this. Also go through the graphs which I have discussed, but in case you want to recollect all those graphs, I'll just quickly revise them for you. Like for example, right? These are the main graphs which you should know. First is position time, then you have velocity time, then you have acceleration time. So if, for example, position time is like this, then velocity will be like this and acceleration will be like this versus time. Similarly, you can also have force versus x graph, acceleration versus x graph, and so on and so forth, because force is minus kx. That's why you will see that the graph will be like this, because force will be minus k times of x, or acceleration will also be minus omega square x. So all these graphs are very, very important. Similarly, for energy also you should know graphs, right? So if you have energy on the y-axis and you have position on the x-axis, then the graphs look something like this. For kinetic energy and potential energy, let me show you the graphs. This is for potential energy. Potential energy is 0 at the mean position. It goes higher on the extreme ends. But if you talk about kinetic energy, guys, if you talk about kinetic energy, then it looks exactly opposite. So kinetic energy goes like this. Okay, it goes like this. Okay, and it becomes minimum at the extreme ends. But their total sum, my dear students, that is always a constant. This is the total sum, which is obviously going to be a constant. So some graphs which you should know. Okay, I hope this is all clear in your head. Awesome. What is K? K is the spring constant, Harshini. Okay, now in fact I'm coming to that also. So imagine if you have any system which is basically like a spring and mass, then if you pull it and leave, it will oscillate. Then the time period of oscillation is given by 2 pi under root of m by k, or you can say omega is root of k by m. From this you can find omega if k and m are given, or if mass and omega is given, you can find the spring constant, and so on and so forth. So this gives you the time period of oscillation. Now whenever you want to find time period or frequency or angular frequency, somehow what you should do is one of these things. Either show, okay, I'll just tell you what and all things you can do. Either show that the force is directly proportional to the displacement but towards the opposite side. This negative sign just tells you if you move it here, the force pulls it here. If you move it here, force pulls it here. It's always opposite. That's why it tries to come back to its mean position, and that's why it ends up oscillating. Or you show that the acceleration is directly proportional to the displacement, right? Or you can show that the displacement is basically a sine or a cosine function of time, right? All these are different ways of showing that it is SHM. Or you show that the energy, the potential energy is directly proportional to x square, right? All these things tell you that it is a simple harmonic motion. One of these things if you do. Is that okay? Yep. Great, great. All these things are important. Also, few more things that you should know is combination of springs. Some of you might have forgotten, but let me just remind you. If you have two springs in series, then the equivalent spring constant is given by this formula. 1 by k springs in series is 1 by k1 plus 1 by k2. It's exactly opposite to the formula of resistors. Think of it like capacitors. So when springs are in series, use the parallel formula for resistors. But if the springs are in parallel, then the spring constant equivalent for them in parallel is just the simple addition k1 plus k2, exactly opposite of resistors. Okay, so that's how it works for springs in series or parallel. You can also use this concept for springs which are cut into multiple pieces. So if you have a big spring, you cut it into small pieces. Each small piece will have these individual spring constants. So these techniques are used for spring cutting problems as well. Now going ahead towards angular SHM, like for example, if you have a pendulum, right, and it goes back and forth, this is a bob, length L, this is a small mass connected to it, it oscillates back and forth under gravity. That is basically your simple pendulum. That is your simple pendulum. Then if you have a big body like this, which is hinged over here, okay, this is the hinge over here, this is the hinge over here, the center of mass may be over here, this is the center of mass at a distance d, then also it might oscillate back and forth. That is called as a physical pendulum. That is called as a physical pendulum. You should know the time period for both of them. For simple pendulum, the time period is 2 pi root of L by G, standard formula. If the time period is 2 seconds, then it is called as a seconds pendulum. Seconds pendulum, that is very, very important. And this G depends on the frame of reference. Frame of reference. Why? Because if you move it left, right, up, down, or in a lift, then the acceleration due to gravity will change. Pseudo force will also come into play. Apart from mg, it could be mg plus a or mg minus a. So you might see problems where a pendulum is, oscillating in a lift which is going up or coming down. In that case, the value of G will change. I hope this is clear. Exactly. Okay. So Isaac Newton, no, omega is not root L by G. Omega is root G by L. Time period is 2 pi root L by G. Yes, Winter. If you cut a spring, the spring constant will double if it is exactly half. If you cut it into 3 parts, it will become 3 times more. That's very non-intuitive, but it is true. Hello, Priya. Hello, Mahesh. Okay. Apart from this, you also have something called as a torsional pendulum, where you take a rod and you connect it to a disc or a mass or a sphere. So when you rotate the rod, all right, it applies a restoring torque back, and the torsional constant is K. This is your torsional constant. This disc or this sphere has moment of inertia I. So this is moment of inertia. Then the time period of such a pendulum is given by 2 pi under root moment of inertia by K. So instead of m by K, it is I by K. That's the only change for a torsional pendulum. Coming back to this pendulum which was left out, physical pendulum. In this case, the time period is 2 pi under root moment of inertia by m GD. That's it. Moment of inertia by mgd. That is the formula. D is the distance from the support or the hinge to the center of mass. M is the mass of the body. I is the moment of inertia about the hinge. That's it. Okay? Yes, this is there in the syllabus. Pavan, I don't know, bacha. It's too difficult to answer. Let's concentrate on the session. Okay? I hope this is clear. This is your, pendulum related theory. Now you can also have problems where SHMs are added, subtracted and stuff like that. In fact, combination or superposition of SHMs is very similar to superposition or combination of waves. So I will discuss that during interference of waves. For now, let's just quickly switch over to the topic of waves. So remember, wave is nothing but transfer of energy. Wave is nothing but transfer of energy without particles moving from the source to the destination. Like when I'm talking, it's not that the air from my mouth is reaching the speaker or the microphone or the audience out there. No, it's the vibrations which are traveling, the energy which is traveling, the particles stay intact. These waves can be of two types based on the medium, whether required or not required. So you have mechanical waves and non-mechanical waves. Non-mechanical waves, example light. Mechanical waves, example sound. You can also categorize them based on whether they are transverse or longitudinal. Transverse, best example, wave on a string. Wave on a string is an example, whereas longitudinal waves example is sound. So in transverse wave, the particles motion is perpendicular to the direction of the wave. The wave goes this way, the particles move up and down, let's say. Whereas in sound waves, if the wave is going towards the right side or left side, then the particles also go along the same direction. So that is the motion of the particles in the direction of the wave. That's the difference. That also leads us to the difference of equations and stuff like that. We'll be coming to that as well in a bit. But before that, general parameters of a wave, we will have a crest and a trough. This distance is your wavelength. The wave will be going with certain speed v. V is nothing but the wavelength into the frequency. V is nothing but the wavelength into the frequency. Right? We'll talk more about superposition in some time, bacha. Yes, I'll be talking about superposition in some time when we discuss interference. Hold on. Okay. Now, Upendra, torsional is not, okay, I'll just come to torsional also. 1 second, just let me complete this slide. So, the wave always will have crest, trough or compression, rarefaction if it is longitudinal, and from one similar point to another similar point is called as the wavelength. Now, also in a wave, it is resembling or it directly relates to oscillations because there is frequency and all of that. So also you have something called as the phase of a wave. You also have a phase of a wave. So if there are two particles, their phases could be same or different. So based on how far they are, you can find out what's the difference of their phases. Their situations could be different. Situation and phase are synonymous, meaning they are similar. So what is their situation like and what is the difference of their situation or phase is called as the phase difference. So if I take two particles, okay, if I take two particles which are separated by a distance of delta x, then their phase difference delta phi will be given by 2 pi by the wavelength into delta x. That is what the phase difference between these two particles is given by. Always keep in mind, from one crest to another crest or one trough to another trough or identical points are separated always by 2 pi radians. 2 pi radians. If separation is lambda cancels, phase difference will be 2 pi radians. Okay, I hope this is very, very clear in your head. Another important thing which you should know. A lot of students do not know this, so I feel that it's my moral responsibility to tell all of you this particular important trick. Remember, it is always the medium which decides the speed of the wave. It is always the source, like the speaker or the person oscillating the string, who decides the frequency. Wave speed and frequency together decide the wavelength. This is the exact order in which you are going to think whether frequency increases, should speed increase or not increase, should wavelength increase or not increase. So all that understanding comes from this. If the medium changes from water to air, speed will change. Source hasn't changed, so if speed changes, wavelength changes. If the source only changes, now you are emitting a sound of higher frequency, higher pitch, then the wavelength will change because the medium is still the same. That's how it is. Okay, 93 percentile to 3K in advance, it is very much possible. Last year also, Riddhi, one student, she did that. She was from Andhra. I took her interview also. It's probably there on the internet, I'm not sure. So she did not score that well in mains, but she studied. In fact, now the gap that you have between mains and advance is much larger. So it is definitely possible to get under 3000 All India rank. Okay, now somebody was asking about torsional pendulum. Torsional pendulum means twisting pendulum. Imagine this pen. I twist it, that is torsion. Twisting is torsion. So if I twist it and I leave it, it will try to come back. As it comes back, it will have some momentum. It will go to the other side. Again it will get twisted. Again it will come back. Again it will get twisted. Again it will come back. So it will twist and turn. Twist and turn. That is called as a torsional pendulum. Just like when you pull a spring, it has a restoring force, Kx. Same way, when you twist a rod, there is a restoring torque. That torque is proportional to how much you twist it. And the constant of proportionality is called as the torsional constant. So here you will see that this torque is basically minus K times of theta. Just like F is minus Kx, your torque is minus K times of twist angle. That's all. Yes, I hope, who was that? Upendra ji, you understood this. And if you know the moment of inertia, you can find the time period. Same formula, 2 pi under root m by k. Here, instead of mass, what do you have? Moment of inertia. And instead of spring constant, what do you have? Torsional constant. That's it. Okay. So instead of F is Kx, here you have torque is equal to K theta. That's all, or minus K theta. Moving ahead, there are different formulas which you should know. I'll just come over here and tell you everything. Okay, so wave on a string. Wave on a string. And here you have sound waves. Sound waves. Okay, so let me make a difference table. All right. So in this case, you have crests and trough. You have crest and you have trough. In this case, you have basically compression and rarefaction. Compression and rarefaction. Correct? That's what you have. Here, general equation of the wave will be given by y is equal to a sine omega t plus minus kx. Correct? A is the amplitude, omega is the frequency, angular frequency, k is called as the angular wave number. I'll just write it over there in some time. In this case, the pressure is a variation. The pressure is a variation, so you will have that excess pressure is maximum pressure difference or pressure amplitude into sine kx plus or minus omega t. Remember these things, that omega is still going to be 2 pi f, k is 2 pi by lambda. This is angular frequency, this is angular wise wave number, angular wave number, 2 pi by lambda, that is k. In fact, you can also say just like v is equal to f lambda, v is also omega by k, standard result. Coefficient of the time term upon coefficient of the x term. Omega by k is also going to be your wave speed. Great. Shall we move ahead? Now this pressure variation also leads to the displacement of the particles back and forth. So this Pm is related to the displacement of the particles in this form. This Pm is also bulk modulus times angular wave number k and into Sm. What is this Sm? This Sm is nothing but your displacement amplitude. Displacement amplitude. Very, very important. This Pm is nothing but your pressure amplitude. Pressure amplitude. This is just your normal amplitude. How much up and down it goes. That is what it is. I hope this is clear. Understood? Shall we move ahead? Okay guys, concentrate on the class or else I'll have to block the students. Indra teacher, RCB, remember this is an educational channel. Make sure you maintain that decorum or else I'll have to block it. Okay. Now, next important thing is the speed of the wave on the string. The speed of the wave on the string, like I said, depends on the medium. So it is given by root of T by mu in this case. Whereas in this case, depending on whether it is a solid, liquid or gas, there are different formulas. For solid, it is Young's modulus by density. For liquids, it is bulk modulus by density. For an ideal gas, the formula is root of gamma RT by molecular weight. R is gas constant, T is temperature only in Kelvin, gamma is your ratio Cp by Cv, and M is your molecular weight, obviously in SI units. B is bulk modulus. Those of you are wondering, sir, what is that B, sir? B is your bulk modulus. Bulk modulus. Modulus. Young's modulus, bulk modulus, shear modulus. Remember that same thing over here. K is angular wave number. Sm is how much does the particle go maximum on this side or that side. Displacement of the particle. Okay, I hope that is clear. Everyone, next important thing is also the formula for your power of the wave or intensity of the wave. The average power of a wave on a string is half mu v a square omega square. That is the formula. In this case, you have the intensity, which is half maximum pressure square divided by density into velocity. So that are the formulas for power and intensity. This is your intensity formula. Intensity is nothing but how much energy falls on a unit area in 1 unit time. Per second, per meter square, how much energy is falling. That is your intensity. Power is how much energy is produced per unit time. This is generally used for strings. This is generally used for sound waves. Okay. What is U? Where is U, bacha? In which formula, Harshini? This is Young's modulus. This is bulk modulus. This is gamma RT by M. That's it. There is no U, I feel, unless I have... Oh, this mu. Acha, this mu. Okay. This mu is nothing but your mass per unit length of the wire. Mu is mass per unit length. Linear mass density. If you take 1 meter, how many kgs of mass is there in that unit wire? That is what it is. Is that okay? Fine. Now, what is the difference between intensity and sound? Sound is a phenomena, or you can say it's the name given to some vibrations which are traveling in liquid or gas or solid. Intensity is the characteristic of a sound. Intensity tells you how intense that sound is. It is describing that sound. How much energy is falling per unit time, per unit area. Okay? I hope that is clear. Now, apart from these formulas, which is basics of sound and waves on a string and intensity and all of that, we will now talk about interference of sound or interference of waves or superposition of SHMs. All of these things are the same thing. Superposition of SHM or interference of waves or interference of waves. Very, very important. So if you have one oscillation and another oscillation or another wave, this has an amplitude A1, this has an amplitude A2. This could be oscillations, this could be waves, does not matter. When you combine both of them, together, you get a new wave or a new oscillation, which is called as the resultant wave, having a new amplitude called as the resultant amplitude. Now, how much is this amplitude completely depends on what are these amplitudes and how much is their phase difference. Like when this wave reaches the maximum value, maybe the other wave is behind. So there is a phase difference. Maybe it's in sync, no phase difference. Maybe it's doing the exact opposite thing, that's out of phase, opposite in phase. So where is the second wave or where is the second oscillation when the first oscillation is doing this? That decides also what kind of resultant is produced. Is it maximum value or is it the least value? Is that making sense? Everyone? Everyone with me? Okay. Now, in order to find the resultant amplitude, what you need to do is first find the phase difference between the waves, which is 2 pi by lambda into delta x. So you all need to know what is the phase difference. After finding the phase difference, you solve the problem using vectors concept, where you use A1 bar plus A2 bar is actually equal to A resultant bar. Meaning what you need to do is show amplitude 1 as a vector. Length of that will be the value of the A1. Show the another A2 not in the same direction but at an angle of nothing but delta phi. The angle should be basically how much, guys? Delta phi. Then using triangle law of vector addition, the missing side of that will give you the resultant amplitude. So basically the resultant amplitude is equal to root of A1 square plus A2 square plus 2A1 A2 plus 2A1 A2, and you have cos delta phi. This is the formula for the resultant amplitude. Yeah, you can use trigonometry, you can use vector resolution, whatever you want to use, doesn't matter. Yep. Good morning, Shreya. Exact transverse versus longitudinal, you can read the difference table which is given in your books, but the basic difference I have already mentioned in the previous slide. Just rewind back a little bit. Okay, I hope this is clear. Great. Now you also have intensity formula. Sometimes you might need it. So the value of the resultant intensity, very similar. You don't have root, you don't have square, that's the only change. So it is intensity of wave 1 or power of wave 1, whatever you want to call it, plus intensity of wave 2 plus 2 root I1 I2 is there here, and cos is outside the root, cos delta phi. That is the change in the formula for intensity or power or the energy of the resultant wave. Is that okay? Now there are two conditions which you should know. If delta phi is 0, then it is called constructive. It is called constructive interference. The two waves or the two oscillations are said to be in phase. They are said to be in phase. If by chance, if delta phi is pi radians, then it is said to be destructive interference. That means if one phasor is here, the other guy's amplitude is on the opposite side, they are opposite in phase, so they are said to be out of phase or opposite in phase. When they are doing constructive interference, crest matches with crest, trough matches with trough, and then the resultant amplitude is maximum and it will be A1 plus A2. If the two are such that out of phase, crest meets trough, trough meets crest, the amplitude is minimum and it is A1 minus A2. That's all. I hope this is clear. Is amplitude depends on intensity? Definitely. Check this out. Intensity proportional to the square of amplitude. Power proportional to the square of amplitude. So energy proportional to square of amplitude always, not just here, but also in simple harmonic motion. Energy proportional to the square of amplitude. Do you see that everywhere the same formula? Some constant will change, that's all, but it is always proportional to the square of the amplitude. That's why I said this is valid for not just SHMs, but also for both transverse and sound waves. Isn't it fascinating, guys? Okay, beautiful. Hello Jeffrey, hello Gokul. Okay, so these are important things that you should know regarding interference of waves. Okay, two waves adding on to each other to give a resultant wave. Moving on to the next point, and that is basically standing waves. Now, what is the standing waves? Standing waves. So, when a wave is moving here and another wave is coming from the opposite side, two waves of same energy moving in opposite sides, you will see that will produce a standing wave, something like this, where each particle is trapped in lobes and the energy also gets trapped in certain regions. Remember, a wave moves the energy from one place to the other. So if wave 1 moves the energy this way, wave 2 moves the energy this way, both the waves together will make the energy to an halt, and in certain places you will see the energy is not at all moving, it's trapped, that's all. So all the energy gets confined in certain spaces or regions. That phenomena leads to standing waves or stationary waves. In that case, you will see the particles are trapped in these loops or lobes. They are called as lobes. Remember that? Lobe or loop. And you have certain particles which move by a maximum amount, like this one or this one, which are called as antinodes. And there are certain particles which hardly move anything. They are called as nodes. Any particle in the lobe will have different amplitude, not like a particle on the wave where all the particles go up by the same amount, come down by the same amount. No. In a stationary wave, the particles have different amplitudes. Different amplitudes. So you will generally see the equation of such a thing is y is equal to 2 times a sine kx or cos kx also you can use. You can also use sine omega t or cos omega t, really doesn't matter. What is a? A is the amplitude of each of the interfering waves. A and A together you will have 2a. Over here, this is the equation of a stationary wave. Okay? Now, how do you create stationary waves? By, number 1, reflecting the sound, and basically you need some kind of an arrangement for that. So if it is a wave on a string, if you have a wave on a string, then you reflect that wave from a fixed end or a free end. If it is sound, you reflect it from an open end of an organ pipe. Basically you take a pipe and you see that you can create these stationary or standing waves. So basically over here you have 3 different scenarios. So let me talk about all these scenarios one by one. The first scenario is when you take a string and you have 2 ends which are fixed. Just one second. Arey, what did I do? Okay, so you have a string of certain length L. This end is fixed. This end is also fixed. Or this end is closed for a pipe. This is also closed for a pipe. In such a case, what you will get is a node on the fixed side or closed side and node also on the other side. And then the formula for the frequency of such a standing wave is NV by 2L, where the value of N stands for which harmonic is it vibrating in. Different possibilities are there. See, for a same wave, I can make the string go up and down like this, up and down like this. Or I can make it go up and down like this. It goes like this and then like this. It goes like this and like this. or I can make it go up and down like this, right? Makes sense? So many possibilities are there. Here n is equal to 1, here n is equal to 2, here n is equal to 3, and so on and so forth. All these are different possibilities of creating these standing waves. So a wave goes, reflects and comes back. So this wave and this wave interfere with each other to produce this standing wave. Different frequencies are possible. This is the most basic fundamental frequency. These are higher frequencies, or I can say higher multiples or harmonics. Okay, I hope this is clear. I hope this is clear. Now, this is one type of standing waves that you can produce. You can also have obviously another type. Like for example, you have one side fixed and other side open. One side fixed and other side open, or basically free end. So this is fixed end or closed end, and this is free end or basically open end. Or you can also have this kind where this is free and that is also free. So this is free side, this is also free side, or you can say this is open side for a pipe and this is also open side. All these are different possibilities, guys. Like you can see again over here, this point now is basically your anti-node. This is your anti-node, whereas this point over here is basically your node. In this case, you will have nodes only here in between somewhere, but on the open or the free side, what you're going to have is nothing but anti-nodes towards the free side. The formula for this and this is the same, guys. The formula for both sides fixed or both sides free is the same. In fact, it is F is equal to NV by 2L. V is the speed of sound, L is the length of the pipe or basically your string. Only for this the formula changes. Instead of NV by 2L, it is nothing but V by 4L, and over here you don't have N, here you have odd number. Here you just have odd number, that's it. You can put 2n plus 1 or 2n minus 1. That's all. Yep, that's the big change in the formula. So this and this have same formula, only this one has a slightly different formula. Keep this in mind. These are all the main things which I am talking about. Obviously more detailed things you can go through the detailed lectures in the Nurture series or in my crash courses or my AI Live courses. The last thing which comes in waves is the phenomenon of beats, which is also interference, and the concept of Doppler effect. So what is beats? What is beats? When similar frequencies are sounded together, what you get is loud and faint sound alternatively. Meaning the sound's amplitude suddenly increases, then decreases. Then sound's amplitude suddenly increases and then decreases. Sound's amplitude increases and then decreases. Max sound, min sound. From maximum sound to another maximum sound, that is called as the beat period. And beat frequency is nothing but 1 divided by your beat period. As simple as that. This beat frequency has a formula F1 minus F2 modulus, whichever is bigger. That's why modulus. What is F1 and F2? It is the frequencies of the two sounds sounded together. F1 similar to F2. You will see when both such frequencies, 400 Hz, 410 Hz, close to each other, and both these frequencies come together, you will see that interference will be such that sometimes the sound will be large, sometimes the sound will be small. Large, small, large, small. It's going to change. Is that okay, bacha log? Everybody with me? Understood? Oh, clear? Oh? Can we move ahead? Oh? Learning, revising a lot? Yes or no? Sir, offline classes soon. It will come. Where do you want, Gopika? Tell me. You want to learn from me in Bangalore? Let me know. I'll teach you. If you guys want Want to learn from me? Fine, let me know. है ना? Great, great. Is it necessary to have same amplitude to form a beat? Luxury, no. But a perfect beat will be found when the amplitudes are same. But there is no necessity that the amplitudes have to be same. You're from Andhra. So you guys want to meet teachers once in a while, but most of the time you want to sit at home, luxury of time. Sir, I will watch the lecture whenever I want to, sir. I like classes also, but my mom gives me nice food, sir. Nice rasam rice is there, sir, at home. Hot rasam rice is there, sir. Morning I'll get idli, sir, dosa, sir, pongal, sir. You know, I get poha, sir. But I want to study at home. Sometimes I want to see the teacher. Sometimes I want to see who is this friend, who is this idiot who keeps troubling me, or who is that legendary fellow who gives the answers every time. You know? So sometimes you want to meet the people. Even I want to meet all of you. So that's why I keep telling you guys, if you want to meet me, let me know. When you guys are coming down to Bangalore, we'll have fun. All right. Now, last thing over here is Doppler effect of sound. Doppler effect is basically apparent change in the frequency of sound due to relative motion. So the formula for Doppler effect goes like this. The apparent frequency is the actual frequency, speed of sound, plus minus. Always on the top you have the detector, and at the bottom you always have the source. That's how it is. D alphabet comes first, in the English dictionary. A alphabet, then B, C, D. D comes first, S comes later on. So it's down. That's all. You need Shreyas sir in Andhra. Andhra Janalu, Andhra Garu, Santosh wants Shreyas sir in Andhra. Fine, bacha. I will come someday. Sir, while studying NCERT, if I don't understand, means I'm seeing your lectures, but in medical college, who will help us? Don't worry, somebody will be there, Gopika. That's why you need to go to a good medical college. Let me tell you, Gopika and others, trust me, your level of studies, understanding improves a lot when you go to a good college. I feel very bad. I won't call bad colleges. See, there is nothing like good colleges and bad colleges. All colleges are good. Everybody is trying to impart education. Everybody is trying to do their best. But that company which you have, that group which you have, the books that you get, the facilities that you get, the kind of teachers that are there, the kind of motivation that they will give, the aura that they carry, the lab facilities, the exposure, the travel, the internships that you will be doing, all those things add up and improve your understanding of the subject. So right now what you are seeing here, maybe till your 11th grade, 12th grade, is just a small piece, or I would say trailer of the big picture. The actual picture is so nice. The actual way of learning will be so much better if you go to a good college, because you are not just learning theory, blah, 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 formula, blah, 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 blah. You are seeing it live in the lab. You are seeing or meeting people who are using it. So that is what is more important in a college, and that's what you will get in a good college. Or I would say the top premier colleges, be it AIMS, AFMC, Government Medical College, or IITs, NITs, BITS, all these colleges give you that facilities. That's why you have to work for that. It's not like you will not be successful from a normal private college or any other local college. You will be probably successful. Definitely, so many examples are there. But your chances, your motivation, your energy increases infinity times when you go to a good college. Yeah. Oh, luxury Hitler. Please change your name, bacha. Hai na? Or maybe they will not take your name on the news channel. Luxury word is nice. The next part, no, Hitler, that is the problem. Okay, a little problem. I don't know. I am okay with Hitler. Other people might have some problem. Okay. So this is the formula. I think we should go to problems now. Yeah. All right. Wow. Next slide is problem. See, there you go. IIT Madras, very cool. Riddhi, it will be very nice. A beautiful campus. I've been there. And tell me how the canteen food is, especially the sweets. I don't know. I had gone 10 years back for competitions and stuff. No, not even 10 years. Oh my God, it's more than 20, almost like 20 years now. So guys, if you have been there or you are going there, let me know how the canteen food is. It's very nice. I used to always go to the canteen and I used to have those sweets. It was amazing. Can you tell about the plus and minus in the previous formula, Nanda? See, bacha, how to use plus or minus? Simple logic. Simple. If it is coming closer, either the source is going towards or the detector is coming towards. Any one of them or both. Okay? Always try to increase the numerator and denominator will try to decrease. So if you try to decrease the denominator, minus. If you try to increase the numerator, plus. As simple as that. If they are going far away, either the source is going away or the detector is going away, then the frequency will reduce. So then the numerator will decrease or the denominator will increase. So if the denominator has to increase, put plus. If numerator has to decrease, put minus. That's all. I hope this is clear. Shagun, I will be now only on the English channels, okay? Yep, that's how it is. Great, great. Let's move on. Okay, so ready for some questions, guys? Ready for some questions? Everyone with me? Here comes the first question. Let's see how many of you can do this question quickly and answer it in the chat box. Santosh saying 1 by 4. Kavya Saran already putting a heart. Thank you, bacha. Thank you so much. Come on. What is the answer to this question? Equation is this. Oh, acceleration plus 64 pi square x is this much. So acceleration will be minus 64 pi square x. So compare, no? Compare with whom, guys? I know a formula. Acceleration is minus omega square x. So if I compare, I can quickly see omega square is 64 pi square. Yes or no, bacha? So take the root. This will become 8 pi. Yes or no, bacha? So omega is known. Question is, what is the time period? Time period is so easy. 2 pi by omega. 2 pi by omega. What is omega? 8 pi. 8 pi. Pi, pi, by. So 2 by 8, 1 by 4. So 1 by 4 seconds. Done, done, done. Great. Option A. What a lovely question. Yes, some of you answered it correctly. Very good, Santosh. Hari's winter is coming. Winter came, winter went, and now it's summer. Change your name, bacha, to summer. It's different season. Please change. Top university or the course taken is important. Both are important. I would say I would always choose university over the course. Unless the course is like really random. So university matters a lot. But at the end of the day, course also matters. It depends, guys. I won't give a direct answer. So you give me the choices, I will let you know what is the better one. Okay? Maybe you can put it in the comments. If a body has amplitude this much, time period this much, at 0 time it was here. The shortest passage from here to here. This is irrelevant data. I think so. Just check this out. I don't think that is relevant data. Just, I think, visualize the situation. The SHM is going back and forth, back and forth. This is the mean position. The amplitude is 17 centimeters. 17 centimeters. Okay. What is the shortest time from 8.5 to minus 8.5? 8.5 is exactly half of this. This is 8.5. This is minus 8.5. This is basically minus amplitude by 2. This is basically amplitude by 2. So to go from here to here, what is the shortest time taken? That's the question. I have an idea now. How about this? Just find the time taken to go from here to here. Just find the time taken to go from here to here. Let's say it is t. Obviously from here to here it will be t. So won't delta t be equal to 2t? Isn't it? Won't delta t be equal to 2t? From this I will get the answer. So how do I find the time? Think, if it was here to go here, or if it was here to go here, how much time will it take? How do I find? Acha, I know what to do. Use x is equal to a sine omega t. X is equal to a sine omega t. Okay, bacha. So what is x? X is a by 2. X is a by 2. Okay. A is a. Sine omega. Omega is 2 pi by time period. Time period is 24. 24. Into time. Oh, I don't know that time. A cancels. Sine is half. That means, whose sine is half? Sine 30. 30 means pi by 6. So 2 pi by 24t is pi by 6. 6 goes with 24. 4 times 2 goes with 4. 2 times pi goes by. So t will be equal to 2 seconds. So 2 into t. T is 2. 2 2s are 4. So 4 seconds is the answer. Exactly. This one is useless data. Confusing students. Gopika, I'll tell you something. If you're not studied 11, no, just open up my nurture playlist, bacha. It's very simple. I don't know how many of you have seen the nurture playlist before this. So it's right over here. As you are on the channel only, no, just go to the playlist tab and you will see beautifully arranged all playlists are there. So just go down, down, down. JEE class 11, you can use it for NEET also, doesn't matter. So you can see nurture maths, nurture physics, nurture chemistry. Just see this full playlist, lots and lots of videos. This for 11th, 12th also you have Pathfinder 12th playlist. Right from chapter 1 to chapter 2. Detailed class. You take any class, like for example, rotation. See, rotation lecture 1, lecture 2, lecture 3, lecture 4, lecture 7. So many lectures. I mean, like, what more you want, guys? So all your basic understandings will be clear, absolutely clear. Chumma given, very good. You guys learned the word, huh? You guys learn all fancy things very fast. Krishna ji, so when will you learn physics so fast is my question, real question. Hai na? Chumma word you guys learned. Sir, suggest me how to read NCERT physics to score 100 marks. Bacha Mahi, please don't read NCERT for theory completely. Understanding should be done from H.C. Verma. NCERT should be used for facts, formulas, figures, diagrams, experiments, or important points or definitions. That's all. So only read the important things from NCERT, but understanding should be done from a different book like H.C. Verma. Oh, you learned it from birth. Tamilian, sir. Okay. Don't chumma read NCERT. Now you will use the word chumma for each and everything, Haris. Anything you want to say, just chumma, put chumma now. What displacement is the potential energy of a particle performing SHM of amplitude 10, 3 times its kinetic energy? The displacement when potential energy is 3 times the kinetic energy. Potential energy is 3 times kinetic energy. At what x? Is x related to energy? Yes, potential energy. We all know that potential energy is half k x square. Okay, great. The amplitude is given. What is the use of amplitude? Acha, I know what to do. I know potential energy plus kinetic energy is total energy. Total energy is half k a square. Yes or no? Kinetic energy, think about it. Kinetic energy from this guy, kinetic energy is nothing but u by 3, no? So just put u by 3 over here. So u plus u by 3 will be how much, my dear students? 4 by 3u is half k a square. Yes or no? 1 plus 1/3 is 4/3. Now what is u? U I know. Oops, what the hell? There is one funny video which I had seen on u. News anchors fighting over the word. News anchor and some specialist fighting over the word u. Like that anchor is asking, I heard in you, the measles came and all of that. Then that other person is like, when did I get measles? Then he's like, no, I'm talking about the series, you. Then that another person is like, no, I never had measles. What are you saying? Why did I have? So it's a very funny video. You should just browse through it. Amazing. U is actually a series. All right. So guys, u is nothing but half kx square. Half k x square. This is equal to half k a square. So things get cancelled out. K, half. So basically your x value will be 3 by 4 a square. So x will be a root 3 and root of 4 will be 2. Amplitude is 10, root of 4 is 2. This is root 3, so this is 5 root 3 centimeters. Isn't that so? Moving on to the next one coming up on your screen. Yes, simple way of solving. I did not complicate the solution at all, just using basic formulas. Frequency of a particle is 24 Hertz, the amplitude is 4, initial displacement is 2. Write the equation. Yes, whatever I do looks easy, but when you do it, then it looks scary. Acha. Equations, let's have a look. Amplitude is 4, so A is basically 4 centimeter or 0.04 meter. 0.04, okay, everything is 0.04. Great. So all these things will work. Frequency is given to be 24 Hertz. F is 24, so omega will be 2 pi f, so it will be 48 pi radian per second. 48 pi, so this is ruled out, this is ruled out. Okay, so only these two options are remaining. This goes out, this rules out. Initially the displacement is 2 towards the negative side, so basically the last point is when time is 0, x is equal to negative extreme, towards the negative extreme, but it is 2 centimeter. X is equal to minus 2 centimeter. So clearly, if I put time as 0 over here, think what will happen? This will become minus pi by 6. Sine minus 30 is minus half. Yes. Here, if I put time as 0, sine plus 30 will be plus half. This value will be positive at t is equal to 0. This value will be negative at t is equal to 0. So obviously this can't be the correct answer, this should be the correct answer. Hence the answer is option B. Many of you said C, Hari said B, very good. Yesterday you solved some questions from DPP, you were not able to understand some questions. So just put probably those questions to your teacher if you are in some coaching, or if you are in the Vedantu app, ask those questions in the doubt app. Third option, you might even ask those things in the comment section of that particular video so others can solve, or if I look at the comment, I will also try to reply to that. Okay. Class 12th and class 11th in 1 month, no Gopika, it is not possible. But important topics, yes. Important topics is possible. Okay. Great. Moving on to the next question. On a planet, a body is left to fall freely. 16 meters it takes, 16 meters it reaches in 2 seconds. Simple pendulum is 1 meter. What is the time period? So what is so strange about this problem is that it is not on Earth, it is on some other planet. So why is this data given? This data is given to find the acceleration due to gravity. How? Time period, or rather time to fall. Time to fall is root of 2h by g is the standard formula. Time is 2, root of 2 into h is 16, g is unknown. So is that right? Yep. So when you square both sides, it will become 4 is equal to 2 into 16 by g. 4 goes with 16 4 times. So g will be 2 into 4, which is 8 meters per second square. This is scary or crazy out. G is not 10. So that is the catch. Many students miss out on this problem. Now use the second part. The length of the pendulum is given. What is the time period? So time period of a simple pendulum is 2 pi root L by g. 2 pi, which is 3.14. Length is 1, correct? G is 8. G is basically 8. Root of 8 is basically 2 root 2. Root 2 is 1.414. Just do the math and see approximately how much is the answer that you are getting. How much is the approximate answer that you are getting? Is it option A, 2.22? So 22 anyways gets cancelled from here. So 3.14 by 1.44 will be 2.2. And I think we can even eliminate the options and get it. Gopika, I would say don't take a drop so easily. I would say try your best. See, even if you get maybe 550 marks or 570 marks, it's still a good thing. You might get into some government college. You know? Maybe not the best, but some government college you might get. So then you can probably just continue your studies, that 1 year will be saved. So try your best to at least get 570, 580, 590 marks. I think it is possible. Okay? Yes, you can take pi as 22/7 also. Next, velocity is given, then the time period is how much? Achha, look at the crazy equation of SHM. Question says, what is the time period? Marine engineering is not there in NIT if I'm not wrong. Okay. Now this equation reminds me of V is omega root a square minus x square. If you square both sides, it will be root V square is omega square a square minus x square. That's how I compare this with. But here x is there with 4. X is multiplied with 4. So actually if you expand it, it is omega square a square minus 4x square. Right? That's, oh, sorry, my bad. Minus omega square x square. So I'm just opening up the bracket. So now if you compare it, you can clearly see this 4 is same as omega square. So to find time period by just comparison, I can clearly see, omega square is equal to 4, omega is equal to 2, omega is 2 pi by the time period. So 2 cancels. So time period will be pi seconds. That's the answer. Just compare it exactly. Pi seconds. Option A. Done. Next question. Luxury Hitler. Oh my God. Thank you for putting it up, and I realized that you got ignored. Sir, we can have personal physics telegram group so we can discuss all the doubts straight with you, right, sir? And also helps to improve our classes. Well, there is a private telegram channel, Luxury Hitler. You can just search IIT, JEE, NEET, EMSAT Shreyas sir or Captain Shreyas. It's my private telegram channel. You can just join that. Okay? But it's a channel. I've not made a group as of now. I will see if I can make a Discord server or something for you guys. I don't know if you guys have heard about Discord servers and all, and you guys use it for productivity purposes. So let's see if we can do something like that. Maybe not on Telegram. Discord server is, I think, more secure or something. We'll see what we can do. Yeah, great. Okay, many students have Discord. But then the community will be good, or it will be very helpful if you have a lot of people. Then you can exchange ideas and stuff like that. If it is a small group, then I don't know. Yeah. Achha, you are pro gamers in Discord. Very nice, Luxury Hitler. Yes. Okay. So what about this question? Force versus displacement. You can see the slope over here basically tells you the value of K. How? Remember, F is minus Kx. When the force is minus 8 Newton, the value of X that you get is plus 2. So minus minus cancels. So K will be 8/2. That means it is 4 Newton per meter. From this K, I can find the time period. Time period is 2 pi under root m by K. So 2 pi under root, mass is 0.25 by K, which is 4. So 2 pi root of 0.25 by 4 is nothing but 1/16. So 2 pi by 4, which is again pi by 2. 2 and 4 cancels, 2 remains. Root 16 was 4. So pi by 2 is the answer, which is option B, of course. Very straightforward question. Looks little different, but it is not that scary also. Okay, so we'll do something, guys, then maybe on Discord. But it makes sense to have a Telegram channel. By the way, that Telegram channel that I have, I'll be sharing all the PDFs, and I'm sharing all the books also, which is very, very useful for all of you. So if you didn't want to waste money on buying books, that channel is there. Okay, great. Moving on to the next question coming up on your screen. A pendulum that beats seconds, that means it's a second pendulum, on the surface of Earth is taken to half the radius of the Earth. What will be the time period? So when you take something on the top, the gravitational value decreases, acceleration due to gravity decreases. So that's why the time period changes. So the pendulum beats seconds, that means the time period is 2 seconds. Okay, initially I can just say it is T1. Now when you take it on the top, the value of G will change. So to find that, I will use this formula. GH is G naught R square by R plus H whole square. Standard formula in gravity. Yes or no? Yes or no? So these type of questions will come in mains. Exactly. Yes, exactly same level. Not very higher than this, not very lower than this. There might be easier. There might be one of tricky question, but 95 to 98% of the questions will be of this level or lower only. Okay, not this question specifically, overall level, whatever I'm saying. So G naught is G, R is R, H is basically R by 2 because it is given half the radius of the earth, whole square. So you can see G naught R square, 1 plus half is 3 by 2. So square it, 9 by 4, R square, R square, R square cancels. So it will become 4 G naught by 9. That is the gravity at height H. Now we all know time period is inversely proportional to the root of gravity because 2 pi root L by G, right? Because it is 2 pi root L by G. So T2 by T1 will be root of G at height H upon gravity on the surface of the earth. So it will be G naught by GH. GH is 4 G naught by 9. 4 G naught by 9. G naught cancels. Root 9 is 3. Root 4 is 2. So T2 by 2. 2 cancels because T1 was 2 seconds. So T2 is basically 3 seconds. That's the answer. 3 seconds. NEET will be obviously easier than this or at this level only. Thermal physics Delhi will not be there, bacha, because I told you that day my throat was bad, so I had to take an off. But if I take that lecture, again my throat will go bad because already lectures are lined up for you every day. So instead I shared the DPP with you for watching thermodynamics related one shot. Use Zero to Hero playlist or Superhero playlist. I've done thermodynamics, everything in one shot, thermal physics. Use that. Or slightly higher, Flash series also there. So it is covered in 2-3 lectures. If you want even more detail, then use the Nurture playlist. Moving on to the next question coming up on your screen. Guys, come on. Tomorrow the mock test is in the morning. Yes, 10:30 physics mock test. 5 o'clock which mock test? Maths. Who is going to teach physics and maths? Write it in the chat box or in the comments. Tomorrow 10:30 physics mock test. 5 o'clock maths mock test, guys. Yes, Capto is going to teach. Okay. Displacement of two particles executing SHM are represented by blah blah blah. The phase difference between the velocities of the particles is how much? Phase difference between the velocities of particles is how much? And I'm thinking tomorrow what I will do is I will share the mock test early in the morning at around 8 o'clock. I'll give you 1 hour to solve it. Some people might start it at 9 o'clock, complete it by 10. 10:30, we'll see what are the solutions. What say? In the morning, I'll share only the questions. You give it like a proper mock test. 30 questions I will give you. What say? 1 hour you take, 1 hour 15 minutes you take. Not more than that. Put a timer. And then at 1 o'clock, I'll share the maths mock test with you. And you solve it, or 1 o'clock, meaning somewhere in the afternoon, I will share the maths mock test just few hours before the session. You solve the maths paper, and then again we'll sit and discuss the solutions. What say, guys? Ready for the challenge? It will be nice, na? Like a proper mock test. You'll get time also to think. In that limited time, it will be like a proper mock test. Let's do that tomorrow then. Okay. So how do we solve this question? Y1 is a sine omega t. Y2 is cos omega t. To compare, I need to bring both in cos or both in sine. So I think this is easier. I can write cos as sine of theta plus pi by 2. So omega t plus phi plus pi by 2, right? Standard conversion formula. Now you can compare the both things. Omega t. The extra thing is this one. So hence the phase difference is phi plus pi by 2. That's it. That's the phase difference. Okay, I hope this is clear. Now, you might be like, sir, wait a minute. Sir, they have asked phase difference between velocities. Arey bacha, whatever is the phase difference between displacement will also be the phase difference between velocity. Will also be the phase difference between acceleration. Will also be the phase difference between force. So don't get confused. Sir, velocity is given. Doesn't matter. Yeah, displacement and velocity have a phase difference of 90. But displacement, velocity, they have a same phase difference. Understood, guys? Clear? Shreya, you'll have to write the mock test from home only, bacha. I'll share the PDF in the Telegram channel. You can just give the mock test at home. That's all. Okay? Let's go ahead. Equation of SHM of three particles is this. If the three motions are superimposed simultaneously on a particle and make it to oscillate, then the amplitude is three SHMs superimposed, meaning vector addition of their amplitudes. Yes or no, guys? So let's do that. First vector has no phase, zero angle. So zero angle, amplitude is 18. So 18 at 0 degrees. Next, amplitude is 6 at 90 degrees. 0, 90. So this is basically how much? It's 6. It's length 6 at 90 degrees. Next, amplitude is 10 at pi radians, 180 degrees. So basically 10 units at 180 degrees. It's basically now adding these three vectors. So I think I know what to do. I'll keep this vector as it is, the vector 6. 18 and 10 cancel out each other partially. What is remaining is just 8. Yes or no? 18 minus 10 is just 8. Now these two vectors can be added very easily because their angle is 90 degree. So what will be the resultant? Root of 8 square plus 6 square, which is basically 10. That is the answer. Very good, very good, very good. See, so simple it is. Looks scary. So 3 SHM, sir, I don't know. Very simple vector addition. Just show the amplitude as a length of the vector. Show the phase as the direction of the vector. That's it. As simple as that. Simple, easy, lemon squeezy, easy peasy. Very good. Next question on your screen. Particle executes SHM. The minimum time after which the kinetic energy will become minimum. Kinetic energy will become minimum. So I will think of it this way. This is time. This is y. So here, y is sine 10t minus pi by 3. So the equation will start with the negative value. It will go up like this, come down like this, and it will go up like this. Kinetic energy minimum. Where is kinetic energy minimum? Minimum kinetic energy. It will be at extreme positions, na? So where is the first extreme position? It is here. It is here. So basically, this is where kinetic energy is minimum first time. That means whatever is there inside should be 90 degrees. Only then the value of sine is maximum. Did you understand? So the value of sine becomes maximum, basically 1. Therefore, whatever is there inside of it, 10t minus, what is it? Pi by 3 will become pi by 2. So this will become 10t, will be pi by 3 plus pi by 2, that means it will become 5 pi by 6, right? LCM. So 5 goes with 10 2 times, and this will become t is equal to pi by 6 into 2, 12. So pi by 12 seconds, that's the answer. Exactly. Yay, that is the answer. Very good. When x is maximum, yes Lisa, correcto. Very nice, awesome. Moving on to the next question coming up on your screen. Two particles execute SHM, same amplitude, same frequency, parallel side by side. They cross each other, opposite direction, when their displacement is root 2. What is their phase difference? Let's understand what is happening. Two SHMs parallel to each other. This is SHM 1, this is SHM 2. This is their mean positions. This is x equals to 0. They cross each other at root 2 distance. So, if one SHM is here going this way, the other SHM is here going this way. The other SHM is here going this way. This distance is basically x is equal to root 2. If this has phase difference 1, phase constant phi 1, this has phase constant phi 2. Question is, what is delta phi, which is basically phi 2 minus phi 1. That's all. So what is this? So I know what to do now. See, generic equation in general, x is equal to a sine omega t plus phi. At t is equal to 0, x is equal to a by root, sorry, not a by root 2, a root 2. Oh, sorry, 1 by root 2 it is there. My bad, guys. This is 1 by root 2. I think that denominator is not seen so clearly. So x is not root 2, my bad. It is 1 by root 2. Okay, 1 by root 2. Same amplitude, same thing. I think that is not even 1. It should be amplitude by root 2 if I'm not wrong. That a is also not printed properly. I'm so sorry about it. This was supposed to be 1, not 1 by root 2. It is a by root 2. Okay. Is that fine, guys? I'm changing it. Yes, Lisa. Thank you so much for pointing it out. Yeah, it is not actually 1 by root 2. It is a by root 2. Is that okay? So, it is actually a by root 2 over here. Anyways, so x over here is basically a by root 2. Okay, this is a printing mistake. Okay. Now, substitute everything. X is a by root 2. A is a. Sine, time is 0. Phi. So basically, sine phi is 1 by root 2. So when is sine 1 by root 2? Basically for 45 degrees and also for what? And also for what, guys? All silver tea cups. So obviously 135 degrees, everyone. So for 45 degrees and for 135 degrees. So this is phi 1, this is phi 2. So what is phi 2 minus phi 1 then? It is basically 135 minus 45, which is 90 degrees, which is pi by 2. That's the answer. So one of the solution represents one SHM because that is also possible. Other angle represents the other phase constant for the other SHM. Because for both these values, x is a by root 2. That is the idea. Yeah, you can also use the concept of phasor diagram and solve it by taking the projections, but I showed you the mathematical way as well. Moving on, next question. Particle executes SHM amplitude 2 cm, acceleration at a distance of 0.5 from the mean is this much. What will be the velocity when the distance is 1 cm from the mean position? That's the question. Let's try and understand. Amplitude 2, acceleration at a distance of 0.5 is 2. Achha. Amplitude 2 centimeter. So for this statement, using acceleration is omega square x magnitude wise only. So acceleration is 2, omega square I don't know, into x. X is basically 0.5 as per the given information. So omega square will be 4. So omega will be 2 radians per second. Okay, but that's not the question. The question is what will be the velocity at 1 centimeter. So to find that, I will use v is omega root a square minus x square because time is not given to me. That's why I'm going to use this formula. Omega, I found it out from here. So that was 2. Amplitude is 2. X is 1. So this will be 2 into root of 4 minus 1, which is 2 root 3 centimeters per second. That is the answer. Yep, awesomeness. Very good, 2 root 3 centimeters per second. Venkat, sir, I have got 99 or 98. You decide, bacha, 99 or 98. Both are good though. Very good. Keep it up. I hope you get 99.9 percentile this time, bacha. Next question. X is a cos pi t by 2. The distance covered by it in time interval between 0 to 4 seconds is how much? Okay. Let's just do this. At t is equal to 0, what is the value of x? It is a cos pi into 0 by 2. Cos 0 is 1, so it is a. Okay. Similarly, what is the value of x at t is equal to 4 seconds? So x naught is basically a cos, what is it? Pi by 2 into t. T is 4. So this is a cos 2 pi. Acha, cos 2 pi, cos 0. Again, it is basically going to be a. Now, so this is at 4, my bad. So x4 is basically a. So at this point also it is a, this point also it is a. Also you can see inside, here it was 0, here it is 2 pi. That means clearly it is understood that 1 oscillation is complete. One oscillation is complete, and because you got this as A, that means it returns back to its original position. A and A, 2 pi, everything points at the same thing. It has completed one oscillation and come back to the same point. So now, if you think of SHM, it goes here, comes back like this. So this is the mean position. It travels A, which is the amplitude, comes back by A and comes back by A. So back to the same point at t is equal to 0 and t is equal to 4. It is at the same point. So the total distance traveled, A plus A plus A plus A, A plus A plus A plus A. So that is going to be 4A. That is the answer. Exactly. No, it is not 2A, bacha. It is 4A. Extreme to mean, mean to extreme. Extreme to mean, mean to extreme. So 4 times. Yes, it is C, Jai Prakash. Yes, Lingesh. I hope this is clear, understood. Then we can go to the next question, guys. Okay? Beautiful questions. Thank you, Amlita Bacha, so much. Okay, beautiful, 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 beautiful questions coming up. So moving on to the next one coming up on your screen now. A child swimming on a swing is in sitting position. I don't know how to draw the diagram of this. Also, he stands up. He's doing all crazy things. A child is swimming on a swing in sitting position, stands up. The time period of the swing will be. I know, guys, there is a printing mistake. Chumma. You know, how can he swim? It will be very fancy to draw a diagram like that. Imagine this is the Pandu who is swimming and this is the swing. And now this is the swing. Crazy. This is that Pandu, whoops, Pandu, who is swimming from a swing in sitting position. Okay, crazy. He's doing some crazy things. Yeah, it is supposed to be a child swinging on a swing in sitting position, stands up. Yeah, crazy. So anyways, he's going back and forth like this. We know that a time period will be 2 pi root L by G. Okay, so what will happen if he stands up? Just think, no, logically, what will happen if this kid stands up like this? What do you think will happen? The center of mass will shift up, effective length will decrease, na? This will decrease. This will decrease. So time period will also decrease because it is in the numerator. That's the answer. Yep. There you go. Awesome. Awesome. There are crazy, yeah, JEE Advanced swag, Krishna. There are many questions which are very weird. And I had asked one question many times, I think to you guys also, or even in my regular classes, that if you have this wild animal, you have heard of this. This is your bear, and what this bear does, it travels 1 kilometer south, then it travels 1 kilometer east, then it travels 1 kilometer north, and it comes back to the same initial point. It returns. So the question is, what is the color of that particular bear? What is that color of that particular bear? Yes. What is the color of the bear? Come on, let's see how many of you can solve this tricky JEE Advanced super duper question which is going to give you all India rank 1. No problem, Aisha. Catch up. How is it possible? Simple. I'll tell you what. Think of the planet Earth. Think of the planet Earth. See, I have the entire world in my hands. You know? I can literally say the entire world is in my hands. Great. Now, imagine there is a bear at the North Pole. It travels 1 kilometer south, 1 kilometer east, 1 kilometer north. It will come back to the same point. Nowhere else it will happen. If it was here in Africa, if it was in Africa, it will go 1 kilometer south, 1 kilometer east, 1 kilometer north. it will come at some different point. But if it is here, south, east, north, same point. So it has to be at the north pole. Which kind of bear is there? Polar bear. What is the color of the polar bear? White color. Hence the answer is white. Done, done, are done. Done, done, are done. Understood? Oh, clear? Oh, amazing. Oh, can we go ahead? Oh, JEE Advanced, All India rank 1 question. This is. Moving on. Here it is. A body executes SHM as maximum acceleration 16, maximum velocity 12. Amplitude is how much? Amplitude is how much? Come on. Maximum acceleration is 16. A max will be when it is omega square into A. A max is 16, omega square into A. I'll just keep it as aside. Next, maximum velocity. V max is omega A. V max is given to be 12. So 12 is equal to omega A. I want to get rid of omega because I want to find amplitude. So I'll square this. So therefore 12 square will be omega square A square. So 144 is equal to omega square A square. Now I know what to do. Take this and divide both of them. Take this and divide both of them. See what can you do, guys? So it will become 144 divided by 16 is equal to omega square A square divided by omega square A. Omega square A gets cancelled. 144 by 16 is 9. So amplitude will be 9. That's the answer. Yes, it is. Are you getting confidence? Super level, Veera level confidence are you guys getting? If you're getting, let me know in the chat box, guys. Yes, so let's move on to the next question coming up on your screen, and here it is. Two waves, this and this, moving in the same direction, superimpose on each other, producing beats. The number of beats per second and the ratio of maximum to minimum intensity. What happens when beats are produced? Loud sound, faint sound. So question is, what is the ratio of the intensity? Come on, my dear students, what's the answer to this? Figure it out. Two waves are there, same direction, superimpose. So you can see, you know omega 1 from here. Omega 1 is 400 pi. You know what is omega 2 from here, which is nothing but 404 pi. So beat frequency, so the beat angular frequency will be 404 pi minus 400 pi, which is 4 pi radian per second, or you can just say 2 hertz. Because 4 pi is 2 pi into 2, 2 is the frequency. So beat frequency is basically 2. I can see 2 here and 2 here. So option B and C is eliminated. Now what about maximum by minimum intensity? I max by I minimum, intensity is proportional to amplitude. So maximum is when the amplitudes add in constructive interference. So it will be A1 plus A2's square. When destructive interference occurs, amplitudes cancel each other and the intensity is proportional to the square of the amplitude. We know the amplitudes. What are the amplitudes? 4 and 3. So 4 plus 3 square upon 4 minus 3 square. 4 plus 3 is 7, 7 square 49. 4 minus 3 1, 1 square 1. So 49 by 1. So where is 49 by 1? It is here, option D. D for donkey. 2 and 49 by 1. Very good, Luxury Hitler. That's a very great idea, bacha. That's a very noble thought. You want to start a JEE education channel. Great. Moving on. Next question coming up on your screen. Source and listener approach each other with velocity equal to half the speed of sound. How much does the frequency change by the which is heard by the listener? Okay, come on, think about it. Let's draw the diagram. This is the source moving with half the speed of the sound. So C by 2. This is the detector moving with again C by 2. So the sound which will be heard by the detector will change by how much? Okay, I have an idea. Apparent frequency is actual frequency, speed of sound, speed of detector, speed of source. Detector coming closer, so sound should increase frequency wise, so put plus. Source coming closer, so frequency should increase, so reduce the denominator. That's how it works. Okay, reduce the denominator because you have to increase the frequency. Increase the numerator because you have to increase the frequency. That's how I get the sign. So original frequency is N, it's clearly mentioned. Original frequency is N. speed of sound as it is plus c by 2 minus c by 2 over here. So this will become n 3c by 2 upon c by 2, c by 2 cancels, so it will become 3n. So the change in the frequency is 3n minus original frequency, so it will be 2n, not 3n. Do not mark 3 answer. Answer will be option B. Many people mark option D. You will lose marks. If you mark answer as D, na, you will lose marks. Always I have told you this many times, every mock test, every single problem solving session, see what is asked. 3n, yes, it is the correct answer, but to the new frequency, not the change in frequency. Give the examiner what he needs or what he wants, not what you have got. There is a difference. Moving on to the next one. A whistle producing sound. A whistle producing sound. Waves of frequency this much, approaching stationary person with this much. The speed of sound is this much. Person can hear frequencies up to this much. What is the maximum value of V for which he can hear? Okay, let's draw the diagram first. Source is there, producing sound. Detector is there, like this. The whistle producing sound and is approaching the stationary source with a speed of V. This is at rest. Okay. Now the maximum frequency he can hear is 10,000. Anything more than that, he will not be able to hear. Now we all know that the apparent frequency formula is original frequency Cc. Here only source is moving towards, so minus Vs. Why minus? Because when source goes closer, frequency increases. That means denominator is small. Now as per the given question, this 10,000, all right, should be more than or equal to the apparent frequency. That's it. If your apparent frequency is within this range, then you can hear it. Hence 10,000 is more than or equal to F naught, original frequency 9500, speed of sound 300 upon 300 minus Vs. See if this makes sense. Everyone with me on this? A lot of things will get cancelled. 0, 0, 0, 0, 0, 0, 0, 0. So this will go on the top like this. 300 minus Vs more than or equal to 95 into 3. Yes, so that is 285. So take Vs on the other side. So Vs less than or equal to 300 minus 285. So Vs less than or equal to 15. So speed of the sound maximum can be 15. Anything less than 15 will work. So answer is D. Answer is D. Yep. Okay. Is that understood, guys? Everyone? God and Jazzy have been arrested for cheating in the exam. Sigma NTA. Luxury. Thank you so much for making channels like that. You will be helping a lot to all the students. And I thought I will see you in the news channel, but not in this way. But okay, some way or the other, at least I will see you in the news channel. You will become very famous. I'll come to meet you in the jail. You want some particular food, you tell me. I'll get that food also. Okay. So, moving on. Closed organ pipe and open organ pipe, same length, produce 2 beats when they are set in vibrations in the fundamental mode. Length of the open pipe is now halved, closed pipe is doubled. Number of beats produced will be... Come on, let's see. Closed pipe and open pipe, same length, produce 2 beats when in fundamental mode. 2 beats. So frequency for the closed pipe, one side closed, one side open, that's what it means, is odd V by 4L. Frequency of the open pipe in fundamental is NV by 2L. Open means open on both sides. So their difference, this is more, this is less. So F open minus F closed is equal to V by 2L minus V by 4L, which is V by 4L, of course. This difference is the beat frequency, which is given to be 2. So V by L is basically 8. This is the first thing which I get, which I might use in the later part. Now for the second part, the length of the open pipe is halved. Closed pipe is doubled. So for the closed pipe, the new frequency will be odd V by 4 length, closed pipe's length is doubled, so 2L. The frequency for the open pipe or N V by 2 length is half, so into L by 2. So this is V by L, this is V by 8L. So the difference F prime open minus F prime closed is equal to V by L minus V by 8L. So 1 minus 1 by 8 is 7 by 8, right? So this will be 7 by 8 into V by L, but V by L, I already know it is 8. So just put 8 over here, 8 cancels, answer will be 7. Answer will be 7. Very good, Santosh, Arvind. Excellent. Option B is correct. If you notice in this question, you will not understand how to get the answer unless you start writing things down. Unless you find what is that V by L. V is not given, L is not given, but the ratio is enough to solve the entire problem because everything comes in terms of V by L. Definitely, Hitler, I would wish to see you in IIT Bombay hostel one day. Definitely, it will be a very proud moment for me and proud moment for you as well as your friends and your relatives and everyone. Very good. Moving on to the next question. Two identical sonometer wires have fundamental frequency 400 when kept under the same tension. What is the fractional change in the tension if one wire is going to cause 8 beats per second when they are vibrating together? Okay, interesting question. So let's have a look. First of all, is the frequency of the sonometer wire related to the tension? Sonometer wire is a standing wave produced on a string under tension by some load or weight hanging. Frequency for such a wire is N V by 2L. Here N by 2L, same velocity is root of tension by mu. That is how it is. If you change the frequency because of the tension, then I can use this formula. Delta F by F is half times delta T by T because the power of T is half, using the concept of errors, relative error, first chapter of your 11th standard physics. Frequency's relative error is the coefficient into delta T, relative error in tension. That coefficient will be the power of tension. Tension's power is half. That's all. Sonometer is nothing but a fixed Venkata Dharma Teja Shankati. Sonometer wala enappa. Sonometer appa, yenappa is nothing but Venkata is nothing but a wire which is attached to a mass. That mass gives tension. Tension is mg. That wire is fixed at both ends. You can change the length by adjusting the length between the wedges. It produces standing waves, and from that you can find the frequency of the tuning fork or any other thing. Okay. So I hope that is clear. Now what do you do? The delta F is the change in the frequency which causes the beats. So the beat frequency is given, that delta F is 8, original frequency is 400 is equal to half delta T by T. This will go on the top, this will become 16 by 400 is delta T by T. So delta T by T, how much will this be, guys? This will be 4 by 100, so this will be 0.04. That is the answer. Option D. Cringe appa. Oops, that really cracked me up. Okay, everyone, done. Moving on to the next question coming up on your screen. A soldier walks towards a high wall taking 120 steps per minute. When he is at 90 meters, he observes that the echo from the step coincides with the next step. The speed of the sound must be. Okay, let's see how do we solve this. So this is our soldier. He's walking, there is a wall over here. Okay, so every step's echo coincides with the next step. So the moment he steps, the sound is produced. That sound will travel. It will get reflected from the wall. That's what an echo is, and it will come back. by the time it comes back, the time gap is delta t. The next step occurs. Next step occurs. Understood, guys? Now it is given 120 steps per minute. 120 steps in 60 seconds. So in 1 second, there will be 2 steps. Correct? So one step will happen in 0.5 seconds. So the time gap is basically 0.5 seconds, yes or no? The time gap from one step to the next step is 0.5 seconds, yes or no? Soldier Pandu. The soldier is like a bullet. Exactly. Imagine the soldier does not even have to fire the bullet. He has to just fire himself up. So crazy. Yeah. Awesome. So now what happens is, guys, if you see the distance that the sound travels, is not just 90, it is 90 plus 90. So 90 plus 90 is speed into time, which is 0.5. Yes or no? Speed into time. Distance is speed into time. That's it. 180 is V into half. So V is 360 meters per second. Done, done, done. Done, done, done. Awesomeness. Crazy. Okay. Ganiyu, I hope you will make it, bacha. All the best wishes and make use of the channel as much as possible. Sir, you can't be able to complete. No, Gopika, you can complete major topics. I'm telling you, with major topics also you can get 570, 580 marks. Okay. So see the video which I have made on NEET English, the high weightage physics topics. Only that many topics will give you 120 marks. Same way you can do for biology, chemistry. Immediately you will get very good marks by preparing, just hardly half of the portions, close to half of the portions. Source producing sound frequency, this much producing, approaching stationary observer, apparent change in the wavelength of the sound. Okay. Yes, let's move on, guys, to the next one coming up on your screen. So over here, what do? Original frequency we know, original wavelength also we can find out. It is speed by original frequency. Speed is how much? 340. Frequency is how much? 170. So this will be 2 meters. That is the original wavelength. In order to find the final wavelength, okay, or apparent wavelength, I can write this as V by apparent frequency. V is V only. Apparent frequency is original frequency into speed, and the source is moving, if I'm not wrong, yes, so into V minus Vs. Just using the apparent frequency formula, F naught V. If you don't like it this way, no issues, guys, I will write it in the standard form upon V minus Vs, standard formula. I can see over here what is happening. This V and this V will cancel, right? So I am going to get V minus Vs, that is 340 minus speed of sound is 17, if I'm not wrong. Yes, 17 upon original frequency is 170. So this is going to be how much, guys? 340 is basically 17 into 20. So 20 into 17 minus 17 upon 170. So lambda apparent will be 17 common 20 minus 1, 19. So 17 common into 19 by 170, this will just become 10. So it will become 1.9 meters. So change in the wavelength will be 2 meters minus 1.9 meters, which is 0.1 meter. That is the answer. Just check it out. Yep. Yes, it is 0.1 meters. Very good, guys. Very good. Gopika Bacha, don't be demotivated. In case you don't know what to do, just connect with me on Instagram. I'll help you out what exactly you need to study and what is the exact procedure that you need to follow. Please don't take tensions, bacha log, okay? When things can be actually very, very simple. Okay, moving on to the next question coming up on your screen. Train is approaching, crossing 120 kilometers per hour, sounds a whistle 640 when it is 300 meters away. What will be the frequency heard by the person standing on a road perpendicular to the track at the crossing at a distance of 400 meters from the crossing? Speed of sound is also given. Okay, I feel we can draw the diagram first. This is 300 meters from the crossing. 300 meters from the crossing. This is the crossing, and at a distance of 400 meters, the person is here. This is the person or the detector. This is the crossing. The train is over here. Okay, now the train is given to move with certain speed. With what speed? 120. So 120 kilometer per hour. So into meters per second. So into 5 by 18 will give you meters per second. So this will go with 6 3 times. This will go with 6 20 times. So this will be 100 by 3 meters per second. That's the speed of the train. So 100 by 3 meters per second. But the sound is going to travel like this. The sound is going to travel like this. So this is the direction in which the sound travels. So you need to take only that component of the velocity which is in the direction of the sound. This is 400, this is 300. Isn't it obvious that the angle over here will be 53 degrees? Isn't it obvious the angle will be 53 degrees? 3, 4, 5. This will be 500 meters. Standard thing. Yes or no? Great. So to find the component, what will you do? Check the component, guys. What will be the component? It will be 100 by 3 cos 53. Yes or no? So that will be 100 by 3 cos 53. Cos 53 is 3 by 5. So 3 by 5. 3 cancels. So 100 by 5 is 20 meters per second. That's the velocity component of the source of the train. So now you can find the apparent frequency. So yes, let's find out. The apparent frequency will be original frequency, which is 640 hertz, into speed of sound, which is 340, speed of sound 340, minus, because the source is approaching the detector, so reduce the denominator to increase the ratio value or the frequency value. So that's why the minus sign. Minus speed of source is 20, this 20 in the direction of the sound. This is a question on 2D Doppler effect. 2D Doppler effect. So always take the components in the direction of the traveling of the sound. So now it's simple. This will be 640 into 340 upon 340 minus 20 is 320. 320 goes with 642 times. 2 into 340 is 680 hertz. That is the answer. Exactly. Very good, guys. Kudos to all of you. Moving on to the next question coming up on your screen. So fine, yeah, I mean, you guys will know what exactly you need to work on by looking at these questions. Yes, that's true. Very good, Jishnu. Awesomeness. Yep. Exactly. Just like Hitler said, Gopika, you have time, make use of this, and everybody is telling you the same thing. I'm also telling you the same thing. High weightage topics. Don't give up. If it doesn't happen, we'll think about drop. But now you don't think about drop. Okay? Moving on. 68 tuning forks are arranged to produce 3 beats with the next one. Frequency of the last fork is the octave of the first. Frequency of 15th fork is. You might be like, sir, in classroom you teach, when you teach, no, it is like sun is a star which gives energy to the earth. Then in the assignment, you give questions like, what is the moon? Then in the test, no, the question is like, if the color of the sun is yellow and the earth is this distance away, then what kind of, solar eclipse will be formed on this day of the month, and find the angle at which the moon will be seen, etc., etc. So what you teach, what is asked in the assignment and what is there in the test are crazy level. So this question also feels like that only, sir. What is this octave, sir, and so many tuning forks, sir? Never you have taught this kind of questions. But actually, I'll tell you, each and everything you know, yeah, this word octave might sound very scary, but trust me, it is not. I'll tell you after a bit. But for now, these tuning forks, F1, F2, F3, like that, F68. Each tuning fork with the next one has a difference of 3 hertz, 3 hertz, so on and so forth, 3 hertz. So, why is it 3 hertz? Because beat frequency is 3 hertz. So the difference is 3 hertz. Yes or no? Acha. I feel this is a AP series. Andhra Pradesh series. Yes or no, bacha? AP series. Common difference is 3. All these numbers are in AP. Yes or no? Andhra Pradesh or arithmetic progression. Agree or disagree? Very good. Now, can I say the frequency of any nth term or nth tuning fork will be first term plus n minus 1 into common difference, which is basically 3. Very good. So now think about it. As per this, 68th tuning fork is the octave of the first. What is octave? Sa, Re, Ga, Ma, Pa, Dha, Ni. I don't know whether it's first Ni or second Ni. Sorry guys. Sa, Re, Ga, Ma, Pa, Dha, Ni, Sa. These are your 7 notes. This note is repeating after that 7th note. Again you get Sa, Re, Ga, Ma, Pa, Dha, Ni, Sa. Sa, Re, Ga, Ma, Pa, Dha, Ni, Sa. It keeps on repeating. Yes or no? Count the number of notes here. 1, 2, 3, 4, 5, 6, 7, 8th. This is the first note. This is the 7th note. This is one set. And the next set starts over here. This is the 8th note. This is called as an octave. Oct means 8. Octave. Collection of 8 notes. Agree or disagree? And whenever you have an octave, whether it is from one sa to next sa, or from one re to next re, or from one ga to next ga, or from one ma to the next ma, the next ma is always double of the first ma. The next re is double of the frequency of the first re. The next sa is double of the frequency of the first sa. Understood? So, if this has a frequency of f1 or whatever, this will have a frequency of 2f1. That's what it means. So, octave means double. Octave means doubling the frequency. In between, there are 8 frequencies, or total 8 frequencies are there in that set. So now think logically. Think logically. This Fn, 68th number, F68 is F1 plus 68 minus 1 into 3. This F68 is twice of F1 because it is an octave as per the given question. So F1 plus 68 minus 1 is 67. 67 into 3. Yes or no? So this will become F1 is 67. 3 is a 201 hertz. Crazy, right? But that is not the answer. That is not the answer. The question says, what is the frequency of the 15th fork? So the frequency of the 15th fork will be F1 plus 15 minus 1 into common difference, which is 3. F1 is 201. 201 plus 15 minus 1, 14 into 3. 14 3 is of 42. 42 plus 201, 243 hertz. So this is the answer. 243. How many of you enjoyed this question? Learned a lot? Learned a lot? So for AIMS, it's a little difficult, Gopika. If your target is AIMS, then I feel that you should take a drop. But I feel that even if you don't get AIMS, it's fine. You can go to a government medical college. Just focus on whatever time is left. Try to complete 100%. Whatever college you get will be maybe not as level of AIMS, but maybe you can get a lower level AIMS. Or maybe you can get some other government college. It's okay. Unless you want to get into AIMS, it's a little difficult. Okay? So sound, songs, music combined with physics and maths. What a beautiful question. So that's what you should learn in day-to-day life. If you just keep on solving problems, sir, I did sound, I did waves. What's the point? Anybody can do that. Any teacher will teach you that, or any book might teach you that. So always try to relate things, whatever you learn with the things around you. You will learn a lot, you will develop interest, and you will do much better in life. Moving on to the next one. Temperature of a gas is increased by 300 Kelvin. The velocity of sound in the gas becomes root 2 times the initial velocity in it. The initial temperature of the gas is how much? Speed of sound and temperature. What's their relation? I know it. Velocity of the sound in a gas is root of gamma gamma RT by M. So it's directly proportional to the root of temperature. So V2 by V1 is root of T2 by T1. As per the question, the velocity of the gas is root 2 times the initial velocity. So V2 is root 2 times V1. So when the temperature increases by 300, so it was T before, now it becomes T plus 300. V1 goes, so root 2 is equal to root of T plus 300 by T, root goes, so 2 is equal to T plus 300 divided by T. So 2T will become T plus 300. So T will become 300 Kelvin. The answers are in Celsius. So this is basically 27 degree Celsius. That's it. That is the answer. Yeah? Great. Shall we move on? C. Yes, option B is correct. Amazing go. Amazing go. Amazing go. Moving on to one more question coming up on your screen. A pipe open at both ends produces fundamental note F1. And the pipe is 1/4 in water, then frequency is F2. What is the ratio? I think direct formula based. So pipe open at both ends. So F open at both ends produces fundamental node F1. So that is F1 and it is NV by 2L or V by 2L. That's it. Okay, V by 2L is F1. Then the second case, 1/4 is in water. If 1/4 is in water, 3/4 is going to behave like a open closed pipe. And for such a pipe, the frequency is given by odd V by 4L. The length is 3/4, so into 3L by 4. 4 cancels, so it will become V by 3L. That is F2. Question is, what is F1 by F2? So that's it. Just take the ratio of both these numbers. So F1 by F2 will be V by 2L upon V by 3L. LL VV goes. 3 goes on the top, 2 comes below. So the answer is 3:2. 3 by 2 is the answer. Mohammed, just watch my thermodynamics classes here. This is a playlist, nurture playlist. See, you will get thermal physics, thermodynamics, everything is there over here. If you want little bit shorter, crispier, then go on the top in the playlist, one shots. Just go to physics one shots, JEE 2023, click on this. You will see wave optics, matter waves, electromagnetic waves, semiconductor, ray optics, electromagnetics, everything. All right, thermodynamics, everything is there over here. So just use these things. If you want little big, not one shot, but not very lengthy, then go over here. Where did it go? Yeah, JEE Physics Quick Revision, Theory and Problems. This playlist. Okay, so this will have not so many lectures, but not a one shot also. This will also have your thermodynamics and all that. Okay, everyone clear till this point? Great. Ready for the last few set of questions, PYQs? Last set of questions, PYQs. Okay, few PYQs coming up on your screen. Get ready, and I hope you guys have smashed the like button by now. If you have not done it, what you guys are doing, do it right away, right now. And if you are not subscribed to the channel, do subscribe right away. When a particle executes SHM, the nature of the graph of velocity as a function of displacement is circular, elliptical, sinusoidal, straight line. Velocity versus position. This is a standard equation. It is basically like this. It's an ellipse. It's an ellipse. And how do you know it's an ellipse? Because V square is omega square a square minus x square. So what will happen? Take it on the other side. So V square plus omega square x square will be omega square a square divided by omega square a square. So V square by omega square a square plus x square by a square is equal to 1. This equation is of ellipse. So hence the answer is elliptical. Yep. Okay. Y by a whole square plus x by b whole square is 1. That's the equation of ellipse. Okay. Moving on. Next question. Time period of a simple pendulum is a stationary lift is t. If the lift accelerates with g by 6, what's the new time period? Moving on. Next question, guys. Time period. New time period will be 2 pi under root L by nu g. The g will change because it is going up. The up is positive, down is negative. So g plus a. So A is G by 6. So this will become 2 pi under root L by 6 plus 1 7. So 7G by 6. So here I can take root of 6 by 7 outside and 2 pi root of L by G separate. Okay, it's the same thing. Equality is maintained. So this will be root of 6 by 7. Why am I doing it? Because this number is the old time period. So this is your old time period. This is your new time period inside the lift. So it's root 6 by 7 times. Yes, that's the option C. C for Captain Shreyas. That's my Instagram handle out there if you want to get in touch with me. Okay. Great. Thank you so much, Gopika. Thank you so much. Sir, maybe today or tomorrow I'll DM you on Insta as I want to get clear path for my JEE 24. Also, motive to achieve IIT. Please help me there. Yes, definitely. And hope your Instagram handle is also the same name, or else I will not know, bacha. The variation of displacement with time of a particle executing SHM is shown. The potential energy versus time graph will be how much, or will be looking in which particular manner. Potential energy is half k x square. K is positive, x square is also positive, so U should always be positive. If you notice, it's negative here. It is negative here. It's always negative here. So all these options are obviously eliminated. Only this option can be correct. Eliminate, completely eliminate. That's all. Nothing else is there. And when x is 0, energy is also 0. Correct. That is also matching. When x is maximum, potential energy is also maximum. So it's exactly matching with that. So option D is the correct one. Perfect. Moving on to the next one, coming up on your screen. Come on, my dear students. A person observes two trains, A reaching, B leaving. So basically there is Pandu. Just imagine, this is our Pandu. Pandu has two girlfriends. So what Pandu has? Pandu has two girlfriends. He says bye-bye to first girlfriend in train A. So the first girlfriend is in train A and she is leaving. Same time, he is very chalu Pandu, very country fellow. Next girlfriend is coming inside. Okay? Next girlfriend is arriving at the same station. Nice it is. Very nice problem. So speeds are equal, 30 meters per second. This is also 30 meters per second. This girlfriend is screaming at him. This girlfriend is also screaming at him at the same time, or whistling or whatever. So their frequencies are given. So he will hear from this girlfriend also from both the trains. What will be the different frequencies, the difference of the frequencies which Pandu will be hearing? That's the question, guys. Understood, guys? Okay, so the difference of the frequencies is asked. Both the girlfriends are shouting. One is leaving, one is coming in his life. Okay, interesting question. So I think it's a Doppler effect question. So frequency by A will be original frequency. Where is original frequency? 300 hertz. 300 hertz into speed of sound 330. 330. Source is moving away, so make plus 30. Frequency of B will be 300, 330, 330. This source is coming towards, so put minus. That's it. So question is, what is F B minus FA? That's the question. Just solve this now. It's not going to be that difficult, okay? And see what is the answer that you're getting. What is the answer, guys? See if it is coming out to be 55 hertz. I'm not going to solve it for you, but just see if you get it as 55 hertz. Okay. Are these PYQs or module questions? No, these are proper PYQs. These are PYQs. Okay, these are the level of PYQs. Okay. Yes, very naughty Pandu. Everybody getting 55? Yes, very good, Santosh Allah. Very good. Shreya, I think minus 30. Yeah, for the next one, plus 30 for the first one. Yeah, very good. Moving on to the next question coming up on your screen. What do we have? Equations of waves are given. These waves are passing through a string. What is the resultant wave? Interesting. Now, if you notice, the amplitudes are different. A1 is 5. Amplitude of the second wave is 3. There is some phase difference over here. I hope you can see that. this wave and this wave, there is some phase difference clearly. So that phase difference is basically 2 pi into 1.5. Just multiply 2 pi into 1.5. That is your phase difference. So which is 2 pi into 3 by 2, which is basically 3 pi radians. Achha. 3 pi radians is as good as saying pi radian. Pi, 2 pi, 3 pi. So pi is same as 3 pi. 1.5 revolution or half a revolution is one and the same thing. So now you can think logically also that if one amplitude is 5 here, the other amplitude will be opposite. That means 3. So the resultant will be this much, which will be 2. So this is your resultant SHM. Resultant SHM's amplitude. So it will be 2 centimeters. So easy peasy it is. Got it? Everyone? Awesomeness. Moving on to the next question. A tuning fork of unknown frequency produces 5 beats with a fork. 5 beats with a fork of known frequency 340. So known frequency is 340 hertz. It produces 5 hertz beats. That means the difference of the frequency is 5. So it could be 345 also, or it could be 335 also. The difference is still going to be 5 hertz. This difference is also going to be 5 hertz. I don't know whether it is 335 or 345. I need to figure that out. So what do? Use the different information given in the question. The beat frequency reduces to 2 beats. That means it can become 342 or it can become 338. So this goes here or this goes here. So that the gap is 2 hertz between the 340 hertz tuning fork frequency. Okay. When does that happen? When A is filed. Filed. This spelling mistake is there, guys. Who has made this? Not field. Filed. Filed means you rub it using some instrument and you remove some of the material. You file it. That's what the meaning is. So when you file it, the mass reduces, inertia reduces, so the frequency, it vibrates more easily, frequency increases. If you take this case, if you file it, the frequency should increase, but this is saying it is decreasing. Here, from 335 it is becoming 338. Hence, this should be correct. This is not the correct option. Hence, the answer will be 335 and not the other one. Did you understand this, bacha log? I'll repeat again. I had 2 options, 335 or 345. As per the question, beat frequency reduced. That means 335 should become 338 or 345 should become 342. So that the gap becomes 2 hertz. If this happens, then the frequency is reducing. But as per the given information, when you file it, mass reduces, inertia reduces, it becomes lighter and can vibrate easily, frequency should go up. So this is not the correct option because frequency is reducing here. Only in this option frequency is increasing. Hence 335 will be the correct one. Yes, it is. So we have come to the final part, and that is your daily practice problems. Where are you going to get the daily practice problems, guys? On the PDF. So all these daily practice problems, you are going to get it in the PDF. So you are going to solve it later on. So I'm just scrolling through all the problems. Just tuck. Yep. There you go. You're going to get it on the Telegram channel. Download it and solve it. Okay. I'll be pasting the solutions also in a bit with the PDF. Okay. Don't worry. Okay. I hope you guys enjoyed today's class. You had a lot of fun also. Tomorrow, 10:30 mock test discussion. 5 o'clock maths mock test discussion. Obviously your Capto will be here and I'll be providing you the PDF little bit early. Okay, I'll try to provide it. I hope you guys enjoyed. Make sure you put up the comments on whatever you want to ask. Feel free to do so, even if you're watching it recorded. Mark your attendance by putting it up in the chat box or in the comment section. Thank you so much. Have a lovely time. All the best for tomorrow. See you guys 10:30 sharp on Saturday. Hasta la vista, Captain Shreyas signing off.